Alright, this is part 2 of your review, starting with 21 going through 40. So this one we're going to do a quadratic function to model the data. So we're doing regression again like we did a couple times on the last problem. And I've already got the data put in here under my editor. So there's the time values, a half, 1, 1.5, 2, 2.5, and then the heights. Alright, they want a quadratic function, and then we're going to use the quadratic function to determine when the ball reaches its maximum height. So when we're going to actually use it, instead of just compute it like we did on the last part, after you press stat and come over here and highlight quadratic regression, notice as soon as you hit enter, it doesn't automatically do it. It has a little cursor here flashing, waiting if you're going to give it any more input. And we're going to click the vars button here, scroll over to y vars, and option 1's function, that's what we want, and then option 1 is y1. And what this is letting us do is, after we do this, we can store that function in y1, and it'll put in the -16, the 50, the 5.5, all that stuff in there for us to use. Now we want to know when it reaches its maximum height. Alright, so a couple things I can do. If I press second y equals, notice that stat plot, I can turn my stat plot 1 on, which all we have to do, I've already got mine on, but all you have to do is highlight on and click enter. Alright, and then once you've got that turned on, press zoom and stat, or sorry, zoom and 9 for zoom stat. Alright, so there's our data points. Alright, those 5 points are these points here, and then that's our model that goes through it. Alright, we want to know the maximum. So to find the maximum, we hit second trace and highlight option 4, and notice it automatically goes to y1. Okay, so left bound, we want to be to the left of peak, so that's pretty close to the peak, but it's a little bit to the left of it. That's what we want. For right bound, we want to get close to the peak but go a little bit to the right of it. And then obviously for guess, that means guess what the max is. Alright, so we hit enter there, and then there's our maximum. So at 1.5625 seconds, the ball reaches maximum height. And they want to know what the maximum height is, so that's your y value, 44.5625. Alright, here's f of x, here's g of x. We want to find g of f of x, and then we want to 23 asks us about 22. So we're going to simplify this after we do it. G of f of x, excuse me, that means the same thing as f of x as the input of g of x. So we're going to put this function f into this place where the x is. Okay, so g is going to take f of x, the entire function, as its input. Well, what does g do to its input? G multiplies the input by 8 and adds 7. So g is going to take f of x and it's going to multiply it by 8, and then it's going to add 7 to that. Alright, well here's f of x. I'm going to put that in where f of x is, and I'll get 8 times x minus 7 over 8 plus 7. Alright, notice here this 8 and this 8 will wipe each other out, and we got x minus 7 left plus the other 7. They're going to wipe each other out, so we end up with just x. Alright, g of f of x is just simply x. Now 23 says, are those two functions in 22 inverse functions? Alright, it certainly looks like they're going to be, because g of f of x is x. But to confirm it, we also need to compute f of g of x, and if it's also x, right, then we do have inverse functions. Alright, so now we're going to put, this is the same thing as putting g into f. So we're going to take the g function, 8x plus 7, and let that be the input in the f function. So what does f do to an input? It subtracts 7, then it divides 8. So it's going to take 8x plus 7, it's going to subtract 7, and then it's going to divide 8. So you can probably see we don't need these parentheses, so you can drop them. Alright, the 7's are going to wipe each other out, and we got 8x over 8, and then the 8's are going to wipe each other out, and we end up with just x. Alright, so since both compositions produce x, then yes, they are inverse functions. Okay, it's not just one way, it has to be both of them produce x when you compose them in both directions. Alright, 24 wants us to find the inverse of this function. So our process to find the inverse, replace f of x with y. Right, and then flip-flop y and x. Let them change places. So we get x equals 8 over y plus 7. Okay, and now we want y out of the denominator. We want to get rid of that y plus 7 in the denominator. So we're going to multiply both sides of this equation by y plus 7. Right, in order to wipe out this denominator. So that's gone. Over here I'm going to distribute that x through, and I'm going to get x times y, if I put the x in front, plus 7x equals just 8 on the other side. Alright, now we want to solve for this y. We want to isolate this y right here. So we're going to subtract this 7x over first, and we get x times y equals 8 minus 7x. Alright, and then finally, last thing, divide away the x. So we get the equation y equals 8 minus 7x over x. Alright, technically the last thing you're supposed to do, if you started with function notation, then you should go back to function notation. And so the inverse function is f with that little -1 superscript up there. Alright, if you wrote this as 8 over x minus, and notice this 7x and x would cancel, if you just wrote it like that, then that would be alright. I'd give you credit for that. But this is fine as well. Either one of those I would give you credit for. Alright, write that thing in log form. Alright, if I want to write this in log form, remember, a logarithm is an exponent. So a logarithm is an exponent. What's the exponent here? T. Okay. Now, that leaves two things left. It leaves this 18, and it leaves p. Alright, well, down here in the logarithm, this is where we write the base. Right, the base of this exponential is 18, so we're going to put the 18 down here, and then the only thing left is the p. So that means p goes right there. Right, so log base 18 of p equals t. Alright, so there's our answer. Find the value of log without using a calculator, and I'll just be standing over your shoulder to make sure when you get to these questions you don't use a calculator. Alright, if you were going to do this without a calculator, log base 10, 0.01 is 100th. and that's the same thing as 1 over 10 squared. 100 is 10 squared. Well, how can I get that 10 squared out of the denominator? I can bring it up and make that 10 to the negative 2 power. Right, and now I have the same base log as I do as the base of the exponential part that's inside the log. So that means this thing is going to wipe that out, and we're left with just the negative 2. Alright, now again, the reason why this is that is because we're looking for the exponent on 10 I need to, or sorry, the exponent I need to raise 10 to get 0.01. So 10 to the negative 2 power is 0.01. Alright, likewise down here, ln is the log base e of e to the fourth. And just like we saw in the last problem, e, 10, 10, these things are going to wipe one another out. And we're just going to end up with 4. Alright, 4,000 invested in encountering 6% annual interest compounded continuously, and the number of years it takes for the amount to grow to 8,000, that is double what we started with, is this. Find the number of years to the nearest tenth of a year. Okay, doesn't get much easier than this. Plug this into your calculator and round it to the nearest tenth. Okay, so natural log of 2 natural log of 2 close parentheses divided by 0.06. So 11.55, so the nearest tenth, that would be 11.6. Alright, nearest tenth of a year, so 11.6 years. Alright, 4x to the 11, or 4 to the x equals 11. Find the exact solution first, then round to 3 decimal places. So if I have 4 to the x equals 11, two things I can do here. I can just bring in any log, like the natural log. Alright, and if I do that, I want to pull an x down in front, and then divide both sides by the natural log of 4 to isolate the x. That's what we want. Anytime we're solving an equation, we want to know what the variable is. So x is equal to exactly the natural log of 11 divided by the natural log of 4. Okay, then round to 3 decimal places. Go to your calculator. Natural log of 11 divided by natural log of 4 is approximately 1.7297. We want 3 decimal places, so 1.730. Alright, now the other way that I was going to tell you to do it, 4 to the x equals 11. This is a base 4 exponent. So if you bring in the log base 4 of 4 to the x and the log base 4 of 11, then just like before, anytime we had the same base as the log as we do the exponent, or exponential part, they cancel, and then that exponent will drop down. So what we're looking for is the log base 4 of 11. This is also the same. This is an exact answer as well, just like this is. But to approximate it, since we don't have a log base 4 button, we would use change of base, and change of base allows us to say that this is the natural log of the original input divided by the natural log of the original base, and now we're right back to that. So either way you started up with it, you could get to this. Now we could also have used the common log, so I could have also said that this is equal to the common log of 11 divided by the common log of 4. Alright, on number 30 we're going to use the change of base form to to evaluate this. So that's basically the same thing we did right here at the end. I'm sorry, right here was a change in base form. When we have a log in one base and we go to another base. So this was a base 4 log and we changed it to the base E, or the natural log. So the same formula we're going to use here. And the way it works is you take the log or the natural log of the original input, so 0.556, and you divide it by the log of the original base, which was 6. Alright, and that gives us a approximation of what this is. So log, the original input was 0.556. Alright, divide by the log of the original base was 6, and that gives us that negative 0.3276. So 3276 to 3 decimal places would be negative 3.28. Okay. Now, what I wanted to also show you is if you would have chosen natural log to do that, you would have gotten the same exact same thing. So log of, or natural log of 0.556 divided by the natural log of the original base is also negative 3.28 roughly. Alright, 31. If the price for a product is given by that price demand function, X is the number of units sold, and the revenue is the product of the price times X. Okay, how many units must be sold to give 0 revenue? So this is what we're trying to find the zeros of. So you're just setting that 1600x minus x cubed. You're setting that equal to 0. Alright, now it's tempting because of that minus sign to add this x cubed over and then divide away an x. Don't do that. Okay. Anytime you have a polynomial set equal to 0, first try to factor it, and we can factor this by pulling out that common x. And we got 1600 minus x squared equals 0. Okay. Now, if excuse me, if you don't see it right now, always try and look. 1600 is a perfect square. If I take 1600 and get the square root of that, I get 40. Alright, so if you didn't see it right there, the fact that we're subtracting a perfect square from a constant gives the potential for difference of squares. So go ahead and see if this is a whole number perfect square. If it is, then you got difference of 2 perfect squares and you can factor it. So this was, so that's going to break down to 40 minus x and 40 plus x equals 0. Alright, set each piece equal to 0, so we get x equals 0. This factored piece equal to 0 would be 40 minus x equals 0, which means x equals 40. Or if this piece is equal to 0, 40 plus x equals 0, then x is equal to negative 40. Alright, now these are our potential solutions. X equal to 0, x equal to 40, x equal to negative 40. But what does x represent? X is the number of units sold. Alright, we can't sell negative 40 units. Alright, so how many units must be sold to give 0 revenue? Well, obviously if we don't sell anything at all, we'll have 0 revenue or 40. So 0 or 40 units. Alright, and then we want to find, and again, more regression. Find a quartic that models this data. Alright, so go to your, put in x is in L1, y is in L2, stat, come over to calc. We want quartic regression, so all the way down to number 7. Alright, and then there's our quartic model. So I'm going to pick or sorry, I'm going to round these to 3. It didn't say, but I'm going to round them to 3 places like we have in some of the others. So that's going to be negative 0.183 x to the 4th. Alright, plus 3.267 x cubed. Minus 20.017 x squared. Plus 51.933 x. Alright, and then the constant was minus 44 even. Squeeze that in there. Alright, so there's our quartic model. Alright, find all the rational zeros of this polynomial function. Alright, rational zeros are those that can be written as a fraction. So when you see rational zeros, we don't need to find imaginaries. Okay, so if there were as an imaginary zero, we don't have to find that. Now, when you do the rational zeros, remember the possible rational zeros come from the factors of this number divided by the factors of the leading coefficient. So the factors of the constant are negative 10, technically positive 10, negative 5, positive 5, right? Negative 2, positive 2, and then negative 1, positive 1. Okay, those are the different factors of negative 10. Alright, and then 3, the factors of 3 obviously are 3, so each one of these could be divisible by 3. Or each one of them could be divisible by 1. If I divide it by 1, then I just get negative 10, positive 10, negative 5, positive 5, negative 2, 2, negative 1, and 1. Alright, so these are the possible rational zeros of this polynomial function. So I'm going to put it in my calculator. I'm going to put it in the y equals screen. Notice from earlier in the practice test we had plot 1 on. Turn that off. Right? I'm going to put that in there. And once I've got everything in, I'm going to go to my table setup. I'm going to tell it to start at, instead of 8, I'm going to tell it to start at 0. Wherever you got yours at, just tell it to start at 0. And then the change in table is 1 for now, because I do have some whole numbers I'll look at. And then go to your table. Second graph is the table. So right away I see 2 is a 0. So 2 is a 0. And then just look around and see if you find any others. There's another one, negative 5. That's a 0. And I'm looking around. It starts to get bigger and bigger into the negative, so we're not going to find any more that way. So go back towards the positives. Those are getting bigger and bigger. I'm not going to find any more that way. So if there is another 0, and it looks like there probably is somewhere in here, then it's going to be one of these other ones with the 3 as the denominator. So what we'd want to do then is go back to your table. Right. This time make your table, you can make it start at negative 4, doesn't matter. I'm going to let it start at 0. Alright, and then make my delta table, my change in the table, a third. Okay, 0.33333333. So I'm going to hit second table. Alright, now it's important that you see, we've already seen that one, but this is 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. If you do that as you go, you don't have to convert these decimals into fractions. So that's -1/3, and there's another 0. So -1/3 is our third 0. Okay, so that's how you can adjust that delta table in your calculator to come up with these zeros. So our three zeros are, you can do it in a couple ways. You can say -5, -1/3, and 2, or you can just list them. X equals -5, x equals -1/3, x equals 2. One more way, just there's never anything wrong with having too many ways to do it. If you actually graph this, I'll have to wait until this gets done so I can put it back in the standard window. Zoom 6 is your standard window. If you graph this, you can get your whole number values from the table, but we can see there is a third value. There's the -5, there's the 2, there is that -1/3, but if since my whole number table set, if I didn't change this to the 1/3, if I kept it at 0 and I kept this at 1, and I only got those whole number values from the table, so I got the 2, I got the -5, and then I went to the graph and I want to use that third intersection to find that -1/3. So again, suppose I don't know that that's what it is. I can hit second trace, go to 0, and knowing that I've already found this -5 and this 2, find this one. So left bound, there was my cursor, I'm going to hit enter right there. Right bound, press to the right, I'm below, so hit enter and then just hit enter again. Now notice it says there's x. Now if you recognize that as -1/3, that's great. If not, second mode to quit, and then just press X. The most recent X that it has stored was from the calc menu when we just did that intersection, and tell it math 1, turn that X into a fraction, and it says -1/3. Okay, so you can do that with any of these rational answers as well. If it can't turn it into a fraction, then it more than likely is not a fraction. It's some irrational number. Alright, use algebra or graph methods to solve that inequality. I'm going to do it by hand. So when you're doing one like this, what you want to do is you want to bring everything to one side. Alright, and once you got it over there, you want to get a common denominator. So our common denominator is going to be just the product of those two things, x plus 7, x minus 2. Alright, so to get this one from x plus 7 to x plus 7 times x minus 2, I had to multiply by x minus 2. So I need to multiply 6 times x minus 2 up top. Alright, and then up here I have a minus in between. Then I had a 2 over x minus 2. Right, to get x minus 2, x plus 7, I had to multiply that by an x plus 7 as well. Alright, and now distribute this -2 through. Don't forget the negative. And you get 6. Distribute this through as well. 6x minus 12 minus 2x minus 14 all over x plus 7 times x minus 2. Alright, combine your like terms. You got a, this is still greater than 0. You got a 6x minus 2x is a 4x. Negative 12 minus 24 more is minus 26. X plus 7 times x minus 2. It's fine to leave that down there. You don't need to FOIL that back out because you need to know what makes the denominator 0, and it's easier to see it when it's factored like that than when you FOIL it back out. Alright, now when you have this, you want to come up with what makes the denominator equal 0. Not just the denominator, numerator and denominator. So negative 7 obviously makes that denominator equal to 0. Positive 2 makes that denominator equal to 0. Then what makes the numerator equal to 0? Well, when 4x equals 26, these cancel. So if I divide by 4, I get x is equal to 6.5, which is up here. Alright, now notice I've got 4 regions. I've got this, I've got this, 1, 2, 3, and 4, created by those 3 numbers. What we want to do is we want to pick a test value that falls in each region. So I'm going to pick negative 10 in this region. I'm going to pick 0 here. I'm going to pick 5 here, and I'm going to pick 10 here. And I'm going to plug each one of these numbers into this expression. Now, a way that you can do that, what I like to do it all at once, is go to your list, your stat menu, your editor. Alright, I'm going to clear out list 1 here. Alright, and I'm going to put in all of these points. I'm going to put in negative 10, I'm going to put in 0, I'm going to put in 5, alright, and I'm going to put in 10. Okay, now keep note, they're in list 1. Alright, come back to the main menu. I'm going to put a parentheses around this because it's all together in the numerator, but I'm going to press 4, and all of those values are stored in list 1. So where there's an X, I'm going to write second 1 for list 1. Alright, then minus 26, close that parentheses, divided by, we need a parentheses to indicate all of this is in the denominator. So I'm actually adding a parentheses here and then a parentheses here for all of that to indicate all that's in the denominator. So there's the parentheses up top. I'm putting a this is that parentheses, so I still need another one here. So parentheses L1 again. Everywhere there's an X, I'm using L1 plus 7. Close parentheses. Next parentheses. There's another X, so I'm going to use L1 minus 2. Close, close. Now what this is doing is it's taking each one of those X's that I put in the list and plugging it into this formula all at once. And then when I'm done, I'm going to hit store in list 2. I hit enter, it does its thing. I hit stat, go to the editor, and now I can see the signs at each one of those test values. So at negative 10 I get a negative. So in this region at negative 10 it's negative. Right, at 0 it's positive, negative, positive. Alright, that's all I'm after is the signs. So negative, positive, negative, positive. Alright, now what do I want? Here's the last thing I did. It's set greater than or equal to 0. So what do I want? I want the stuff that makes the output positive. So I want this region, I want this region. Alright, so how do I write my answers? It's just those regions. This is negative 7 to negative 2. That's going to be part of it. We can use interval notation. This is 6.5 to infinity. Okay, it keeps going on and on and on. Now, I haven't put the parentheses or brackets yet because I haven't determined what they're going to be. Now, this has an or equal to, so normally we put brackets everywhere, but notice -7 and 2 both make the denominator equal 0. So they can't be included no matter what, even though there is a bracket. So I have to use a parentheses for them. Alright, but 6.5 is okay. 6.5 doesn't cause division by 0 anywhere. It causes 0 up top, but not division by 0. So 6.5 will get a bracket. And then the parentheses, or sorry, the infinity symbol always gets parentheses. And then put a union symbol in the middle. Don't forget that union symbol. You'll get a point or two taken off if you forget it. Alright, so there's our answer to do that. Now, if you did this graphically on your calculator, it's almost like cheating, but since I showed it to you earlier in the semester, I'll show it to you again. But you just write basically this exactly like you see it. So 6 divided by, you do need a parentheses if you have any operation in your denominator, so x plus 7, and then you put that symbol in there. So math, or not math, sorry, second math test, there's the greater than or equal to symbol, option 4, right? And then 2 divided by parentheses x minus 2, close parentheses, and then this, look at this, hit graph, and where that thing gets raised up like that is your solutions. Okay, if you go to your table, the ones mean it's true. That means they're part of the interval. Alright, and look where the ones start. They start right after -7. Alright, error at -7 because that causes division by 0. But then ones, meaning that's part of the solution, and then it stops at 2. Alright, and then 0, that's not part of the solution, and then it picks back up between 6 and 7. Now, because 6.5 is in there, right, you would need to make your table set like 0.5. Right, now you can see that it's picks back up at 6.5, and then it starts being true again. Alright, so again, that's, to me, that's almost like cheating. It's like giving you, here's the answer in the number line form. Alright, compute A times B if possible. These are 2 by 2 matrices, both of them, so it is definitely possible. Alright, remember the way we do this is this row times this column, component wise, so -1 times -2 plus 3 times -1. Alright, and then that'll be a +2 minus 3 and -1. Alright, and then we do it again. This time we do -3, or sorry, -1 3 times 0 3, and that'll be the next number, the top right number. So -1 times 0 is 0, plus 3 times 3 is 9. So we end up with 9 in that second position. Alright, and then once we're done with everything on the top row, we move to the bottom row. Alright, and we get 4 times 2 times this first row. Sorry, 4 2 times this first row. 4 times -2 plus 2 times -1. Right, equals, that's -8, -2 more, so -10. Right, and then finally 4 times 2, or 4 2 times 0 3. Sorry, so 4 times 0 plus 2 times 3. Alright, 4 times 0 is 0, 2 times 3 is 6. So the product of these matrices is negative 1, 9, negative 10, 6. Alright, now you can also put that in your calculator. Again, yes, I don't have any problem with you doing that. Alright, other question. This one, if A inverse equals this, solve AX equals 489 for X. Since this is A inverse, to solve this for X, we're solving for that X, we need to multiply both sides of this equation by A inverse. Alright, A times A inverse will make this A go away, and we'll have X equals this thing times this thing. So you're just multiplying these two matrices together. So I'm going to throw both of these matrices in my calculator and do the multiplication. Alright, so this first matrix is a 3 by 3, 3 columns, 3 rows. Alright, and notice I put the fractions in there. Negative 1/8 is negative 0.125. When you put it into your calculator, it's going to change it to a decimal. Sorry, it's no big deal that it does that. Alright, always before you start making the next matrix, back out and then go back in, so you don't put a matrix inside a matrix. Alright, we're going to edit the next one. This is a 3 row by 1 column, so this is a 3 by 1. Alright, and then we're going to put in 489, and then we're just going to multiply these matrices. So second quit, come back in, call matrix A, call matrix B, multiply those together. There's our solution. Now, it's fine since those decimals terminate if you leave it as decimals, but if the decimals don't terminate, just remember you can always change them to fractions with that into fraction, even in the matrix menu. So X equals 21/8, Y equals 33/8, and Z equals negative 1/8. Alright, graph the inequality. So to graph the inequality, I need the x-intercepts. So again, this is another one like we saw before. Negative 2 divides 10, negative 5 divides 10, so use the intercepts. So y-intercept occurs when x is 0. So if I let x equal 0, I get negative 5y, and again I'm going to temporarily say equals 10. So y equals negative 2. So y equals negative 2 is right there. Alright, and then the x-intercept occurs when y equals 0. Alright, so if I set y equals 0, this part's gone, and I've got negative 2x equals 10. So x equals negative 5, which is right there. Alright, and if I connect those with a line, right, something like that. Now, when we shade this, I'm going to use this to shade it. We have to determine which side do we shade it. Now, the way I do it is pick the origin. There's the origin. If I plug the origin into this equation, 0, 0, 2 times 0, 0, minus 5 times 0, 0. 0 minus 0 is 0. 0 is less than 10, so the origin is included in what makes this true. So the origin is included in what we shade. So all this above that line gets shaded. Alright, so all that's shaded. That's all part of the solution. And nothing below that line is part of the solution. Now the line is solid because it's an or equal to. If this line, or sorry, if this were not underlined, if it was strictly less than, then we would have a dashed line right there. Alright, graph the the graph of the boundary equations for the system inequality is shown. Find the corners of the solution region. Now what you have to understand here is it could be this region, it could be this region, it could be this region, it could be out here. We have to go by what goes on here. So I'm going to use yellow for this first one. Alright, 0, 0, the origin makes this true. So 0, 0 is going to be included in what's shaded here. Now x plus y equals 6 has 6 and 6 as its x and y intercepts. So this is that line. This is x plus y equals 6. So I'm going to shade in towards the origin for that one. Alright, and then the next one, I'll pick blue for 3x plus y less than 12. Alright, that's going to be the other one. This steeper line, right? It has an x-intercept at 4, it has a y-intercept at 12. So that's that one. Again, the origin makes it true. So I'm going to shade underneath it, since that would include the origin. Alright, now, what am I looking for? The green region, what's shaded in both of them. Right, and then x greater than 0, y greater than 0, that's the first quadrant. So that means the points that we're looking for, our solution are the boundary points, are all those points on the corners of the green region. Alright, so those corners are 0, 6 right there, 0, 0 the origin, 4, 0. Alright, and then this is the one you're going to have to solve for. Right, it's the intersection of this line and this line. So we have to set up and solve this system of equations to find that intersection. Alright, so easy to do. You can just change the signs of this top one. Alright, now these combine to a 2x. The y's cancel. 12 minus 6 is 6 divided by 2 divided by 2. So x is equal to 3. Alright, then plug that in. That means y is also equal to 3. So that means the other point that we have to check, or if we had a function to maximize, would be 3, 3. So those are the 4 points that bound that green region. Alright, here's our objective function. This is what we want to maximize. So we're going to plug these points into that function and see what we come up with. So plugging in 0 and 38.5 into that thing, I get 7 times 0 is 0, so 6 times 38.5 gives me 231. Alright, and then plugging in 1133, 7 times 11 plus 6 times 33 equals 275. So 7 times 11 plus 6 times 33 equals 275. Alright, and then the last one is 55, 0. I don't need to check the origin because obviously that's not going to make it bigger than, that's going to make it equal to 0. Alright, 6 times 0 is 0, so just 7 times 55, and we get 385. Alright, so to maximize it, it's maximized here when x is 55 and y equals 0. Alright, so the maximum possible one is 385. None of these, again, a maximum or a minimum is going to occur on the boundaries, not going to be on the inside. Alright, and then for number 40, we've got to come up with the boundary. We've got to come up with everything. Alright, so I put a basically just a quadrant 1 graph in here, or a grid in here. It's mainly quadrant 1. It has a little bit of the others. But we're going to come up with what that little region looks like. So x greater than 0, y greater than 0 means we're dealing with quadrant 1, right? But then I want to come up with these other two lines. So 40x plus 80y, again temporarily I'm going to say that's equal to 560 instead of greater than or less than. Alright, so the x-intercepts of this occur when y equals 0. So 40x equals 560. So x equals 4 goes into 56 one time, remainder of 1 14 times. So x equals 14. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, that'll be the biggest one. 3, 4. So there's 14. Okay. The y-intercept occurs when x equals 0. So I got 80. Y equals 560. Alright, divide both sides by 80 and you're going to get y equals 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Alright, connect those with a straight line. Alright, now I could keep it going the other way, but I'm quadrant 1 only, so I really don't need to. Okay, and then the origin does make this true, so I'm going to shade below. Alright, now next line. 6x plus 8y equals 72. So again, the x-intercept occurs when y equals 0. So 6x equals 72. Divide both sides by 6. I'm going to get x equals 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, and then cover up the x. 8y equals 72. So that means y equals 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to connect those with a straight line. Alright, and once again, the origin makes this true, so I'm going to shade below it. Alright, and notice I've got a green region again, just like I did last time. So we're after the green region, and we really want the boundaries of that green region. So that's the origin, that's the y-intercept of that line, the intersection of the two lines, and the x-intercept of this line. Alright, so this is the 6x. This line right here is the 6x plus 8y equals 72. Right, and this other line right here is the 40x plus 80y equals 560. Alright, so if I want to come up with what the red dots are, and this one's not included, I'm going to change it to a black dot. This is not included. Right. So just the red dots. The coordinates of this is the x-intercept, or sorry, the y-intercept of this line. Alright, or you can just count it. 1, 2, 3, 4, 5, 6, 7. Alright, so 0, 7 is one of the points we have to check. Alright, again, because I'm maximizing this, if you look back at the problem, I'm maximizing it. The origin technically is a possibility, but I immediately throw it away because there's no way it's going to work because I'm adding x and y together. Alright, I need the x-intercept of this line. Alright, so the x-intercept occurred when y was 0, so that was 12. Again, you can count it off if you want to. Alright, but there's only one more point, so it's the intersection of these two. So if I want to find the intersection, I need to solve that system that contains these two lines. So that's 6x plus 8y equals 72. 40x plus 80y equals 560. Alright, I'm going to take that top equation and multiply it by -10 to get this sign change here, and I'll get a -60x minus an 80y equals a -720. Alright, 40x plus 80y equals 560. Alright, that cancels. When I add it together, I get a -20x equals, this combines to a -160. Alright, and then divide both sides by -20, and I've got x. Alright, so x equals 8. Alright, we can see that 1, 2, 3, 4, 5, 6, 7, 8. Alright, and y is going to end up being 3, but plug it back into either of these originals. I get 6 times 8 plus 8y equals 72. Alright, that's 48. So I'm going to subtract 48 from both sides. Alright, 72 minus 48 is 424, and then 8 goes into 24 3 times. So y does equal 3. Alright, so the last point that we have to check is 8, 3. Right, the intersection of the two. Alright, and do just like we did on the last problem. Once we know these points, plug them in and see what we get. Alright, an easy way, or in my opinion, an easy way to do this, use your stat menu again. Alright, highlight L1, clear it out. Highlight L2 and clear it out. Alright, put in your x coordinates that you're going to check in L1. Put in your y coordinates that corresponded to those in L2. Alright, and then go back to your objective function, what we're trying to maximize. Alright, this 8x plus 12y. And remember, we got the x's in L1, the y's in L2, so we're going to press 8 L1 plus 12 L2, hit enter, we get 84, 96, and 100. So that means 100 is the maximum that we can get, and that occurs at this 8, 3. Right, the maximum is 100 when x equals 8 and y equals 3. Alright, there is your practice test. Alright, it will not take you this long to do it. There won't be this many problems on it, but do practice this over the weekend. Practice some of this stuff on the calculator to help you, because it does help a lot to be able to navigate through that calculator.